This video is over solving inequalities. We will solve inequalities just like equations. But there's only one rule when you divide or multiply by a negative number you flip the sign. So everything else is the same except when you multiply or divide by a negative number, your inequality sign flips around. So let's look at some examples. We are going to solve, graph, and put into interval notation. And when we solve, we actually have the inequality. So these two should be in your vocabulary, or you should know those two vocabularies where you're asked, well, what is the interval notation, or what is the inequality? Okay, so this first example, we can go about it one of two ways. We can divide by 7 to both sides and then solve, or what most students and people will do is they will distribute that 7. And then subtract the 7 to both sides. And then divide by negative 21. Now when we divide by negative 21, our sign flips. So this will be r is greater than 5. Negative 5, excuse me. And then we will graph. And how I graph, I just place a number line with the target number, which is negative 5. This will be open circle since it is strictly greater than, and it's not equal to, and we need all values greater than negative 5, so everything that is greater than negative 5 will be to the right. And then with interval notation, we'll have the open circle and parentheses go together. So we start at negative 5, and it's not actually a value that will work, but we can get really close to it, all the way to infinity, positive infinity. $325 divided by 4 is greater than 5 times negative 15 over 4, x plus 2. Here we have some fractions, and what we're going to do is multiply by the common denominator. Now this right here, this 5 times this quantity, this is a whole term since it is a 5 times a quantity, or you can think of this as 5x. We are going to multiply by 4 to each side and each term. 4's cancel out, giving us 325 is greater than 20 times negative 15 over 4x plus 2. Don't worry, when we multiply by 20, the 4 will cancel out. So 4 goes into 25 times, and then we will have to multiply by negative 15. which will be 75, or excuse me, negative 75x, and then 20 times 2 gives us 40. And then we're going to solve like we should. So 325 minus 40 . 285 is greater than negative 75x. We're going to divide by negative 75. Which that will not divide evenly, so we are going to reduce. So we can actually divide 5 out of both numbers. So we'll have 57 over 15, and this will be a negative. Since we divided by a negative, we have to flip the sign, and we have x. Now, this can reduce again by 3, because 7 plus 5 is 12, and if 7 plus 5 is 12, and 12 is divisible by 3. So this will be negative 19 over 5. And then our trick is when we graph, our trick is when we graph, we must have the variable first, because our sign will show us which direction our arrow is going. So to graph, I will place negative 19 over 5. This will be open circle to the right, and then we'll have parentheses negative 19 over 5, comma, infinity. Okay, so make sure we flip the sign when we divided, and then we had to flip the sign again so that we could write our x first. So anytime your x is last, you can flip it completely around and pretty much have a mirror image. Compound inequalities are a little different. We have two sides instead of just one side. Now, if you would like, you can write the left side out and then write the right side out separately if that will help you. Otherwise, I've seen students put a little dotted line down each part where the inequality is, so that they remember when they add or divide, they have to hit both sides. So we have to add 3 to both sides, or I should say to all of the sides, inside and the outers. And then we divide by 3. Now, a lot of students I've seen will flip this sign because 18 is negative. That is false. You cannot do that unless the 3 is negative. So if 3 is negative, you can flip the sign. Otherwise, it's positive. Our signs stay the same. Now, to graph this, we'll have negative 6 and 10. Make sure you're in order. Open circle at both points. A has to be greater than negative 6, which would be a line going to the right, and then everything less than 10, it would be going to the left. And if you visualize it, we will actually have 2 lines going in between these dots, and that's what we want. We want the intersection. So this will be parentheses negative 6, comma, 10. $38 is greater than or equal to 5x minus 7, which is greater than 8. Now, typically, we don't necessarily see this written out in this fashion. Usually, it's from least to greatest, but I'm not going to change anything about this until we finalize our answer. So I'm going to do my little trick of putting my dotted lines. I'm going to add 7 to both sides. And then we divide by 5. 9 is greater than or equal to x, which is greater than 3. To finalize the answer, we're going to flip this whole thing around. So our numbers read from least to greatest. And then we graph. We have 3 and 9. Open circle at 3, and then since 9, it says x is less than or equal to 9, we have to have a closed dot above 9 because 9 can work. We can replace x with 9 and it still holds true. And then since x is in between there, our line connects the dots. We'll have parentheses 3, comma 9 with a bracket. The bracket and closed circle go together, saying that that is included. And then we have another compound statement. We can have two different statements. Where we either have to have this inequality to hold true or this one to hold true. If they're both false, then we cannot use the value that was chosen. So we're going to add 10 to both sides, divide by 2, b is less than or equal to 8, and then this one, b is greater than 9. So when we graph it, we have 8 and 9. Make sure those are in order, otherwise you're not going to get the correct answer. The 8 has a closed circle because we can replace 8 with, or b with 8, and it still holds true. And we want everything less than, and then with the 9 we are open circle and we want everything greater than. And then to write this as an interval notation, you go parentheses, negative infinity, because we're coming from negative infinity, comma 8 with a bracket, a u for the union, and then parentheses 9, comma infinity. So this right here, that's the interval notation. No, not no intervals. I'm sorry, inequality notation. Okay, so this is the inequality notation. This is the interval notation. So make sure you understand the distinction between those two answers. We also have some inequalities, just like equations. We have some inequalities that have infinite solutions and no solutions. So as you're working the problem, if the variables cancel out, you're left with a statement. And this statement could be true or false. So if you have, let's say 0 is less than or equal to 5, that is a true statement. So we would say all solutions, and the interval notation for all solutions would just be in negative infinity to infinity. But all solutions, for my preference, would be fine. I've seen students use this before, and that's fine as well. Depends on what your teacher is wanting. If we have 2 is greater than or equal to 5, well, this is a false statement. So any false statement would be no solution, and then the symbol is empty set, which is hard to find or type on the computer, so no solution will suffice. This is only if the variables cancel out. You're left with a statement. Just as if you had an equals or an equation, 5 equals 5, well, that's true. And if you had 2 equals 5, well, that's also false. So the same thinking with both of those holds true, or you do the same thing with the inequalities. This concludes this video.